What if we keep digging into the earth, not because we are searching for gold or fuel, but because curiosity refuses to let us stop? What if we decide, together, to push past every limit and see how far the ground beneath our feet truly goes? Imagine us standing at a vast drill site, feeling the low vibration through the soles of our shoes. Above us, the sky looks calm and ordinary. Below us, the planet hides a world we barely understand. We often say we know Earth well, yet we have explored the surface of Mars in greater detail than the depths beneath our own cities. Digging has always been a quiet act, but its consequences have never been small. From the very beginning, we have been diggers. Long before technology or written history, we dug for roots, water, and shelter. The ground was both a provider and a challenge. As time passed, digging became more than survival. We began pulling metals from the earth, learning to shape tools, weapons, and machines. Copper led to bronze, bronze to iron, and iron to steel. Each layer we reached transformed the world above it. Entire civilizations rose and fell because of what we found underground. In the modern era, digging has reached an entirely new scale. Mines stretch kilometers beneath the surface. Tunnels pass under oceans and mountain ranges. Drills cut through rock that has not moved since the planet was young. At this point, we are no longer digging only for resources, we are digging for answers. We want to know what lies beneath simply because it is there. If we decide not to stop, the Earth quickly reminds us that it is not an empty shell. It is a layered system shaped by immense forces. The crust we live on is thin and fragile, more like a skin than a foundation. Beneath it lies the mantle, a vast region of hot rock that moves slowly over millions of years, carrying continents across the planet. Deeper still is the core, a blazing heart of metal that plays a crucial role in making life possible. The deepest hole humans have ever drilled reaches just over 12 kilometers. It sounds impressive until we realize that Earth's radius is more than 6,000 kilometers. Compared to the size of the planet, our deepest efforts barely scratch the surface. Everything beyond that point remains hidden, understood only through seismic waves, laboratory experiments, and mathematical models. Most of our planet exists beyond direct human experience. As we dig deeper, heat becomes our first major obstacle. Temperature rises rapidly with depth, overwhelming conventional machines. Metals weaken, electronics fail, and cooling systems struggle to function. The deeper we go, the more energy the Earth pushes back at us, as if the planet itself is resisting intrusion. Digging stops being a mechanical challenge and becomes a battle against extreme conditions. Pressure soon becomes an even greater problem. Rock presses inward from all directions with crushing force. Caverns collapse almost instantly. At great depths, empty space cannot exist for long. The Earth closes in, sealing itself faster than we can carve it open. Every meter downward demands more advanced engineering and more careful control. Still, we imagine a future where we do not give up. We develop materials that can withstand extreme heat and pressure. We design cooling systems capable of removing vast amounts of energy. We rely on autonomous machines guided by artificial intelligence instead of human operators. Slowly, impossibly, we reach the boundary between the crust and the mantle. The mantle is unlike anything on the surface. It is not a lake of lava, but solid rock that flows over geological time. It moves so slowly that its motion is invisible to us, yet powerful enough to shift continents and reshape oceans. Earthquakes and volcanoes are born here. Mountains begin their rise in this hidden layer. By reaching the mantle, we stop being distant observers. We become participants inside the planet's machinery. The Earth is no longer just something we live on. It becomes something we are inside. As we continue deeper, conditions grow increasingly alien. Minerals change their structure under immense pressure. Sound behaves differently. Density increases, and gravity subtly shifts. This environment is far removed from the world human bodies evolved to survive in. It is shaped by forces that challenge our understanding of physics and material science. Eventually, we approach the outer core. This region is a vast ocean of liquid iron and nickel, hotter than the surface of the sun. Its constant motion generates Earth's magnetic field, an invisible shield that protects the planet from solar radiation and cosmic storms. Without it, the atmosphere would slowly erode, and life on the surface would face extreme danger. At this depth, digging becomes more than exploration. It becomes interference. Disturbing the core could weaken the magnetic field, affecting navigation systems, satellites, and communication networks. Over time, radiation levels at the surface could rise, placing biological life at risk. The very systems that make Earth habitable could begin to unravel. This happens because Earth is not just layers stacked together. It is a complex system. Pressure balances temperature. Motion creates magnetic fields. Chemical and physical processes are tightly linked. Changing one part of the system can send ripples throughout the entire planet. Removing material or altering internal structures could redistribute stress along fault lines. Earthquakes might increase in frequency or intensity. Magma chambers could destabilize, leading to more powerful volcanic eruptions. None of this would be intentional. It would simply be the planet responding to disruption. Despite these risks, human history suggests we would struggle to stop. Exploration has never been safe. Fire burned before it warmed. Electricity shocked before it illuminated cities. Nuclear energy terrified humanity before it powered entire regions. Progress has always required facing danger rather than avoiding it. There is also the possibility that digging deeper reveals something unexpected. Not just rock and metal, but structures or formations that challenge our understanding of natural processes. While mainstream science considers this unlikely, history reminds us that certainty often precedes discovery. Meteorites were once dismissed as superstition. Continental drift was ridiculed. The universe itself was once believed to be unchanging. Digging has a way of rewriting what we think we know. This leads us to a deeper reflection. We dig downward while building upward. Skyscrapers stretch into the sky as tunnels descend into darkness. One direction reaches for the stars, the other reaches for the planet's heart. Both are driven by the same desire to push beyond limits. Perhaps digging is not really about resources or knowledge. Perhaps it is about refusing to accept boundaries, about proving that no place is forbidden, not space, not atoms, not even the Earth itself. Yet a species that reaches everything risks losing something essential. Mystery fuels imagination. The unknown keeps us humble. If every layer of the planet is mapped and measured, wonder may begin to fade. Curiosity thrives on unanswered questions, not final conclusions. Some thinkers propose that Earth responds to disruption, not consciously, but mechanically. Throughout its history, the planet has gone through cycles of change. Ice ages reshaped climates. Magnetic reversals altered radiation exposure. Mass extinctions reset life itself. Each time, balance was restored through dramatic transformation. Excessive interference could accelerate these cycles. From this perspective, digging too deep is not just exploration. It is a disturbance that forces the planet to correct itself. Still, there is another future we can imagine. A future where we dig responsibly and intelligently. We learn how the planet truly works. We harness geothermal energy on an unprecedented scale, providing clean and constant power. Earthquakes become predictable. Volcanoes are managed. Climate systems are stabilized from below rather than patched from above. In that future, digging becomes cooperation rather than conquest. The Earth is no longer a resource to be exhausted, but a system to be understood and respected. Even then, restraint matters. Just because we can reach deeper layers does not mean we should do so without reflection. Wisdom lies not only in how far we can go, but in knowing when to slow down. At the same time, hesitation carries its own risk. Civilizations that stopped exploring eventually fell behind those that continued. Progress has always favored those willing to face uncertainty rather than hide from it. When we dig into the Earth, we are also digging into ourselves. Our curiosity, our ambition, and our fear of the unknown all surface together. The planet has layers shaped by time and pressure. Human nature has layers as well. Somewhere between the surface and the core lies a reflection of who we are becoming. The depth we reach will not be defined by machines alone, but by the choices we make together. If you enjoy questioning reality and exploring ideas that push beyond the familiar, subscribe to Beyond Theory and keep digging deeper with us into the mysteries that shape our world.